After making the pivot mount for the flatbed camper, the next task was to complete the walls and get the shell assembled. We still had to build the bunk floor and front, cab wall, and the back wall. Here Steve had raised the roof up so we could move the side walls into position and get them braced on the floor. Once they were braced and stable, the roof was moved into position. The hoist wasn't quite doing what was expected of it, and things were a little perplexing for a bit. Once the roof and the walls were completely aligned, Steve was able to go back through and glue the pieces together and use the pocket screws to complete the assembly. Now he can continue to build the additional walls, which continue with the same construction showed in previous episodes. In this episode, Steve provides more detail of where and why he used aluminum throughout portions of this mostly wood camper construction.
I'm getting ready to put the insulation and the grid work inside this rear wall, but in doing so I thought I'd take a few minutes to discuss my incorporation of aluminum tubing as a stiffening and strengthening member inside the walls. I've done this in the ceiling, in the floor, and now this is the back wall. And as you can see here, I'm standing in what will become an access door. And this is fairly wide, so above this door I have this aluminum tube here. This is a 2-inch square by 3/16 inch wall. Actually, this is a 1/8 inch wall tube here to strengthen the top of the door frame, because this door will hinge upward and the door will actually mount on the top of the door frame, so that's fairly substantial. Over here on my right hand side, this is the driver's side where the spare tire will be mounted. So this big aluminum section here is going to be holding, you know, a 75-pound tire, if not more than that. So this is fairly necessary. Here on the passenger side, this is the inside of the wall here. The outside of the wall is here. I'm going to probably have a fuel can mounted here. And so in this particular case, I wanted a wider bearing. So instead of using square tubing, I've got some 2-inch by 1/8 aluminum angle here. Now, all of these materials are attached differently. The key element that I want to do is to make sure these materials incorporate well in the other structural bearing members in the wall. So you have to remember that the skins of the wall are connected to each other through the use of these pieces of wood to create a structural stress skin panel. So I want to make sure that the aluminum and the stress skin panel are all incorporated. So in this particular case, you can see this piece of aluminum is mounted to a piece of wood, and those two are screwed together, and so the wood will be allowed to, through the glue, incorporate into the stress skin panel and support it that way. What I've done here with the aluminum tube here is that you can see right here at the end of this aluminum tube, there's 4 screws here. What I have done is inside of the aluminum tube is a very tight fitting wooden block inside of the end of the tube that's inserted in there, and then screws are screwed from the side of the tube into that block, and then once it's incorporated into the wall, that wooden block is glued here, plus it's screwed into this. So this aluminum tube is very securely attached to this member here. And then on either side of the tube, in this particular case, since this supports a spare tire, there's pocket screws attaching that piece of wood to the bottom frame here. And so this tubing is secured to this bottom frame with 2 screws here, 2 screws here, and 4 screws here. And this bottom section here will be connected to another floor panel. So there's some pretty secure mounting in here, at least I think it's pretty secure. But that's what I wanted to show you, how I've elected to incorporate aluminum into the skin here.
Back wall has a 30-degree departure angle and will have storage and seating on the interior. This design actually includes both an upper window hatch and a lower solid fold-down door that you'll see him constructing here as he puts the back wall on. The outside corners will be covered with an aluminum plate. This serves 2 purposes. One is to protect the corners from tree branches and shrubs, and the other is to provide wiring channels for the outside lights on the back and on the bunk nose.
I thought I would take a few moments to talk to you about how these structural insulated panels are being secured to each other to create a continuous internal waterproof membrane and an external waterproof membrane. The walls and the floors, when they were constructed on the table, they were laid up with fiberglass. The walls received 6 ounces of fiberglass cloth on the outside and the inside, and the floor had 25 ounces of fiberglass on it. But once they're put together, the floor has a seam of waterproof glue applied to the edge of it, and the wall is set upon that waterproof glue. And I use pocket screws to secure those joints, those seams together. Once that has set up and the entire structure is squared and plumb, everything's connected. Now what I'm going to do is inside the camper, I'm starting to do the treatment in here. And what you see here in this joint between the floor and the wall is 3 layers of treatment. The first layer is a mixture of polyester resin and milled glass fiber thickened to a state that's referred to as peanut butter. And so that peanut butter is spread into the sharp corner here and treated with a radius tool of about 1/2 to 3/4 inch radius that gives a very smooth transition. This allows the fiberglass to smoothly go through through a 90-degree turn while still adhering completely to it. If you see this, you'll see that this is all single color. There's no air in here. So what is done is that once that peanut butter is dried, is cured, I take a die grinder with a small diameter stone and I run it entire length of the seam, and that fillets the radius to a flush on the edges, and it makes a very smooth transition. And then I apply 2 layers of 6-ounce fiberglass, one strip about 3 inches wide, and you can see this one here has got some color to it because I snapped a chalk line on it, and that's chalk powder inside the glass fiber. And then there's another piece about 8 inches wide that goes from here all the way over to here, and that completes the entire seam. And since the floor and the wall are already covered with fiberglass, that is a structural bond. This fiberglass, this polyester resin, is non-wax resin, so it's designed to include to allow for additional layers of laminate to be included on it. As you'll see right here, this section of floor was not pre-laminated on the table, and so in here we have the 2-inch seam in the center and an 8-inch seam over the top of it, and then eventually when I get around to it, this will get another 3-ounce or 6-ounce layer over the entire thing. Here you can also see the evidence of the pocket holes which secure the floor sections together. These pocket holes are also filled with this peanut butter, so they're packed full and then sanded before it's allowed to cure. So this is the structure that holds it together on the inside. On the outside, we're going to do something similar, which is to say we're going to have 2 layers of fiberglass over every jointed corner that will bond the layers of pre-applied fiberglass together and basically provide a very secure barrier for any kind of moisture.
We will be taking a break from building this camper until the fall while we do some traveling this summer. When we resume the camper build, the next steps will be to finish the fiberglass reinforcement on all inside joints, cover any remaining outside joints, and fiberglass the full roof. Well, I hope you enjoyed that. That was episode 4. This week has been pretty busy. We are getting Mr. Lance ready to roll. Have a good one.